Hi everyone. Today we are going to look at a problem called finding permutations. This is lead code number 48. So basically the idea behind permutation is, let's say we have some number, it could be numbers or it could be strings also. Basically for each position, fill it with all the possible values in the set. So when we say 1 2 3, it's basically a set of items, right? What are the possible ways in which we can sort of arrange this? So it will be something like, let's say 1 2 3 is a valid one, then we'll have, for instead of 1 we can maybe have 2, sorry, let's do it like this: 1, then we can do like 3 2, then we can have like maybe 2 in the first place, then we can have like 2 1 3 etc, right? So basically there's a funda on the number of possible permutations, so that works like this. So basically we have 3 positions to fill, right? And when the first element, when we are trying to fill it, we have 3 possible values, right? Because there are 3 possible elements. Now for the second position, you have already taken one position has been already filled, so the choice now becomes out of 2. So you, out of 2 you can pick up one element, and when you're filling the third element you have like one position. So that's roughly that's 6 actually, right? So for string of n elements, you have like n factorial permutations. That's the mathematical way of looking at it, and it's not very hard to do this. Let's say if you want to find visually what are the possible permutations, you can very well arrive at it. So the way I can think of this is, I can kind of create a tree kind of a thing. So let's say instead of 1 I choose to put 2 3. These are my other possibilities. Then I know that within this 2 3 itself, I could choose to put 3 for the next element, right? And likewise, if I'm choosing 3 as my intermediate element here, I could put 2 here, right? So you can see that this 1 2 3 is actually one of the permutation, and 1 3 2 is another permutation. Likewise, let's say if I'm choosing 2 as my middle element, then my other possible elements for the second row is basically 1 and 3, right? And then I can, within this one, let's say if I choose 1 as my second element, then my other possible value is 3. If I am choosing 3 as my second element, my other possibility is 1, right? So you can see how this structure could be easily arrived at just for completion. So this will be 2 comma 1, right? So you can see that there are basically 6 leaf nodes in this tree, which is corresponding to the 6 possible values that you can arrive at. Now when we are doing, so there's basically a divide and conquer pattern to it, which is why when we are coding up the solution for this, it's possible to do this in a recursive manner. So let's think of that. How can we do this programmatically? It's fairly easy to do this when we are just like writing it in a scratch pad. How do we do it a little bit programmatically? So a way to think of this is, let's say we have a list like this 1 2 3. So basically, see, what we can do here would be, we can say that 1 I have chosen as my current value for that position. Other than 1, if I choose 1, what are the other possible values that could come here, right? So it's essentially like we pick our num as 1 here, okay? Then I have a possibility of getting 2 comma 3, right? Now okay, so within this 2, let's say I choose 2, right? I choose 2 as my num. Then what is the other possibility that I remain? That's 3, right? So basically when the len of list becomes eventually even this will get there will be a point when this will become an empty list, right? So when a len of list becomes 0, you can understand that you have reached the leaf node, and you can basically aggregate whatever nums you have till that point and save it somewhere. So have like a result array which starts with an empty list, and every time when you find this num, you keep on appending that num, rest dot append of num, right? You do it, so now you have 1, then when you find 2 you add 2, then you find 3, and your terminating condition is basically when the len of list is basically empty or it is 0. At that point what you do is like you have, let's say, another array called solution array. So you just append that solution array, sorry, result array to solution array, that's it. Yeah, so and then the recursive call could be made to do the same thing for other things. So that's the idea. The key part is basically, selecting this remaining list. So let's say if I select 1 at this point, how do I select basically the remaining list? So let's say if it is, let's say if I'm choosing 1, 2, 3, and if 2 is my chosen point, basically what I have to do is I have to select all the elements till this index point and have that as my left array, and then I need to have my right array which will basically have just this element, right? And it's basically left array plus right array which gives me the remaining list. So that's the funda for this. Let's see when we try to call it up. Okay, so first thing I'm going to do is I'm going to create basically a variable that we would use to store our final solution. I'm going to call that self.solution and I'm going to create it as an empty list. Okay, so now what we would do would be we will define another recursive function here inside this function. I'm going to call it permute recurse, and what it will take is it's going to take a nums array and it's going to take a result list actually to store the intermediate result between each permutation. So my terminating condition is if len of nums equal to 0, then basically what I'm doing is I'm going to append it to my result array. I will just append it, right? Now this is what I will be doing. I'm going to iterate to the my nums, len of nums, and I'm going to select basically my number. My number is going to be what, nums of idx, right? That's my number. Now I need to get the remaining list. So we discussed about getting a left array. So a left array is going to be just going to be this, right? Everything till that idx point, and my right array is going to be nums of idx plus 1 till the end of the array. Now I'll call it the remaining rem array or something. It's basically left array plus right array, right? So okay, now what I have to do is I have to call this function recursively and then pass basically my remaining array, and then I had to pass basically result plus what is my num, that is because this is expected to be a list, I will put it in a list and send. Okay, so here what I have to return eventually would be self.solution, right? Now I can call permute recurse. I will pass basically nums and then an empty list. Let's give it a shot. Yeah, that seemed to have worked. Yes, and it has been submitted also. Yeah.